I am inviting the CEO of RISC-V International, Andrea Gallo.
I'm just moving here, so I'll look at this screen here. I will not turn around. So thanks for the invitation. Thanks for having me. And it's great to be back in academias, because this is the roots of RISC-V. And if RISC-V is so popular and successful, is thanks to all the students worldwide. Last year, RISC-V turned 15. So it all started as RISC-V in 2010. But the term RISC goes back to the early 80s. In UC Berkeley, California, in the parallel lab by Dave Patterson. Dave Patterson himself, he came up with this reduced instruction set computer concept. I will not go back to that history, but a few years later, I was a summer trainee in Cambridge at Acorn, and I worked on the ARM2 chip and as a student. And they shared an article with me, a paper that described, explained that the first ARM1 chip was designed after reading the papers of the RISC-V project. So it's all siblings. So it all goes back to the early 80s. And RISC-V is the 5th generation of the work by Dave Patterson. And it started as a project for academia, just like everything you have described so far. In 2010, Chris Stezanovic, Andrew Waterman, Yoon-Sup Lee, they were all part of the parallel lab by Dave Patterson. And that was May 2010. Their conclusion was that they needed a new ISA for all their research, and exactly as Stefan was saying, sharing between the different departments. Few years later, when they started changing something in the documentation, somebody from India complained, "Why are you changing the RISC-V standard?" And he said, "Which standard? What is it?" So they had not realized that few years later, it had already gone beyond academia. It was being used beyond UC Berkeley, and it was being used worldwide. So they established a RISC-V Foundation. And just a few years later, in 2015, Western Digital was using RISC-V in all the disk drive microcontrollers. And NVIDIA adopted RISC-V for their GPUs. So if you click on that QR code, you will read a blog post that describes the history of RISC-V with quotes from Andrew Waterman, from Chris Stezanovic, from many of the people that have been involved in RISC-V so far. So RISC-V, from our perspective, we should look at the RISC-V ISA as an open industry standard, just like USB or Wi-Fi or the internet protocols. These are open, publicly available international standards that you can download from the website for free. And then you can do your design. Wherever you are, in California, in Europe, in India, in China, you can do your local designs compliant to the specifications. And RISC-V is the same. So RISC-V is a standard that describes an instruction set architecture, describes the contract between the hardware and the software. And RISC-V International, which has taken over the RISC-V Foundation, RISC-V International is now incorporated in Zurich, in Switzerland. And so RISC-V International is a non-profit association that oversees the maintenance and the evolution and the roadmap of the RISC-V ISA. So we are a global organization, evenly distributed across all the geographies. There is not one geography that is taking over the others, doing more or consuming more. Last year I visited many events of RISC-V worldwide and universities, and I have seen the same level of maturity across the globe. Not one doing more than the other. RISC-V International last September was recognized by ISO IEC JTC1 as a standardization body. Last September, we got accepted by ISO IEC to be a PAS submitter. PAS means publicly available specification. So the ISO IEC folks, they review the way of working, the policies and procedures, how we develop the specifications in a transparent way, how we log consensus between all those that are participating. And they stamped that the way we are working is aligned to ISO. So the next step is that we can submit the RISC-V specifications for evaluation by ISO, and hopefully, that will be our goal, of course, hopefully they will become an ISO standard. So that's one of our big goals. I heard this already by all those who spoke before me. RISC-V helps in academia, in startups. You can share what is being done by one team and reuse in the other team. So researchers, startups, all are participating and evolving RISC-V. But it's also very important for multinational companies and for countries, because RISC-V brings freedom, brings the confidence that everyone can control their destiny. Every semiconductor company can rely on multiple IP vendors who are designing RISC-V implementations, even open source implementations or commercial. And every company designing an IP implementation, they know that the specifications are publicly available under the Creative Commons. There are no licenses or royalties beyond the Creative Commons license. So nobody will change the rule of the game overnight or lock anything out. So RISC-V is giving you the confidence that you can control your destiny, and many companies are investing in RISC-V to build their long-term roadmap without a single vendor lock-in. So that's the independence that RISC-V is bringing beyond the technical side. And so wherever you are in the world, you invest locally. And thanks to the standards, you all engage globally all together, as we are seeing this week with these RISC-V World Days. But where is RISC-V used? This is a chart by the analysts by SHD Group, and their analysis is that in 10 years, between 2021 and 2031, so in just 5 years, RISC-V will grow from 2.5 to 33.7% of market penetration in all these markets. In all the markets, industrial, automotive, networking, and so on. I mentioned Seagate and Western Digital. NVIDIA disclosed that they are using between 10 and 40 RISC-V cores in every GPU. In every NVIDIA GPU, there are between 10 and 40 RISC-V cores. Just in 2024, NVIDIA estimated that they shipped 1 billion RISC-V cores, just NVIDIA in 2024. Qualcomm is using RISC-V in their wearables, and there are public talks that go into the details. RISC-V is now used by Infineon for all their automotive roadmap. All the semiconductors by Infineon for automotive are based on RISC-V. RISC-V is used in AI accelerators, is used in HPC, in data center. So all the markets that you see here. And the change over the last 3 years has been that we have been moving from just an horizontal technology play, so RISC-V for AI at large or security on RISC-V, to focusing also on industry vertical. So automotive, data center, embedded. Last year we launched the automotive SIG, the special interest group, and a space interest group. We're now looking, we have a data center one, we're now an HPC, we're now looking in industrial edge as the next area to focus. Everything we do in the end is PDF, is specifications. In 2025 we released 14 specifications. There's a big backlog on security, on matrix. So in 2026, we estimated we will be above 20. You see that the specifications cover performance, they cover security, they cover development with debug and tracing, and a lot about standardization and the profiles. So just to try and explain what the value of a profile, the core RISC-V ISA is 40 instructions. And then there are about 100 of extensions that add floating point or bit manipulation or security or vector operations. So all these are extensions, modular and all composable like Lego blocks. So this means that everyone can design a different RISC-V implementation. And how do you ensure that software runs, or you don't have to port compilers and operating systems for every single variant? So we are building these profiles. Profiles are like recipes or configurations of RISC-V for specific applications. So there's application processor profile, RVA. The latest version is the RVA23 that we released in October 2024. We're working on a microcontroller profile. And then around these profiles, so this minimum set of extensions, for example, for an application processor, you need all the security extensions. You need floating point, you need vector, you need hypervisor support. Then you can have an application processor to run Linux. Then, if you start standardizing some of the peripherals around the core for a specific market and specific bootloader and software services, then you target industry verticals. The example is the server. We released a server SOC, and we're now about to release a server platform specification. So we're standardizing the I/O MMU, the clock and timer, the interrupt controller for PCIe, for example. All together, focusing on ACPI, that's the server platform. And from there, you have Red Hat, Ubuntu, SUSE, or you focus on Yocto, then you're looking at embedded Linux or the automotive-grade Linux. So this is the concept, how things evolve from the core base ISA to extensions to profiles, platforms, and the software ecosystem. And so RVA23 is the last one that we released, the most important so far. On one side, we have a growing list of companies that have either IP designs for the RVA23 or even silicon already available, like Tan mentioned the K3 by SpaceMeet. And there are a few others that are ready and that are being announced on a daily basis. And on the software side, when we release the RVA23, and again, it means that an operating system can be built for an RVA23 configuration, and then you will have binary compatibility at the application level on all those chips that are compliant with RVA23. So you build it only once. Ubuntu for RVA23 will run on all the RVA23 compliant chips. So Ubuntu only supports RVA23 now. Red Hat has a developer preview for RISC-V. In the Yocto project, now we have RISC-V on par with x86 and ARM. We're passing the same test, and we're part of the official build for Yocto. And NVIDIA last July disclosed that they are building plans to port CUDA to RISC-V, and in particular to the RVA23. So you see that on the hardware and on the software side, RVA23 is bringing this alignment, is setting the bar high for the evolution on the application processor. And so if we now close on the adoption side, how to get involved with RISC-V, we have a growing library of free online courses on the website. These are all free. I think only the RISC-V fundamentals may require a fee. All the others are all free of charge. The certifications may be at cost, may have a charge. But all the courses are free of charge. And there are two that I took as soon as I joined RISC-V, the fundamentals. But my favorite one is building a RISC-V CPU core. And I think that every software engineer shall take that course. It's to design the hardware of a RISC-V CPU. A very simple one, single stage, everything happens on a single clock cycle. But every software engineer shall take that course. And then you can get some of the certifications. And the latest one is porting software to RISC-V from other ISAs, which is again free and important one. We are now starting a RISC-V community challenge. This is led by the Technical University in Graz, but everybody can join. And it's going to be exciting because they will be developing a pipeline RISC-V core. And so we have all these RISC-V days worldwide, all the events worldwide. Thank you for having organized this one. And the next event will be the RISC-V Summit in June 2026. It will be in Italy, organized by the alma mater in Bologna. And the call for paper is open. So if you want to submit your abstract for your talk or for a poster, do it now, quickly. There are a few days left. Thank you. Thank you very much.